All right. So let's find one where we actually compute something. Let's go to about 18. That's we're bound to be computing something by then. Okay, refer to the technology. Values if n equals 5, p equals that, clinical test of drug. That many subjects were treated with that. Each case, 5 subjects were randomly selected and treated with 10 milligrams of the drug. What's the probability that more than one subject experiences headaches? Is it reasonable to expect that more than one study will do headaches? So this one, they're kind of nice. They went ahead and did the probabilities for us. We could have found them if we wanted to. Actually, let's talk about that. How would we get those numbers if they didn't give them to us? So if they tell us, hey, if you're doing 5 trials, the probability of success on one trial is 0.761. How do we get the probabilities for 0, 1, 2, 3, up to 5 successes? Okay, so again, you just go, it's binomial distribution, so binom dist. The number of trials, so that's our x. The number of total trial, the number of successes is our x. The total number of trials is 5. The probability on one trial, if I remember right, was 791. And we want the exact values rather than cumulative, so 0, right? Did I remember the number right? No, 761. Instead of 791. There we go. So again, they gave them to us in this problem, but to get them, you just use the binom dist guy. Okay, so if you want the probability of at least 2 people getting headaches, that's what they asked for, right? Yeah, more than one subject experiences headaches. So how would I do that? More than one is how many? 2, 3, 4, 5, right? 2, 3, 4, 5. So I go sum of the 2, 3, 4, 5. That's it. Is it reasonable to expect that more than one subject will experience headaches? Well, the probability that one or more is 98%, so yes, it is. Wait. The event that the number of subjects that experience headaches is less is unlikely. Yeah, there we go. That one's doing the same thing. One where we're actually have to find the numbers ourselves. Let's go about 21. 9 P's parents, so there's that individual P will have a green pod. Find the probability that among the 9 offspring P's, 8 have green pods. Is it unusual to get at least 8 pods with green pods when 9 offspring P's are generated? Why or why not? Okay, so let's do this. So first of all, we want to get we want to get at least 8 green pods, right? So let's do this 2 different ways. Let's go 0 equals and go up to 9. 7, 8, 9. So one thing we could do the same thing we just did. So say binom dist our x. How many trials are we doing? Well, we want to get at least 8. How many are we actually doing? 9. And the probability each time is? It was 75. And in this little chart, I'm doing them one at a time, so I'm going to put 0. That's a very small number. Okay, so if we want at least 8, what would we do? Yeah, just add up the 8 and the 9. All right, so three decimal places, so it's just going to be 300. All right. The other thing we could have done, so remember, Excel will do this cumulative thing for us. So, but I want 8 or more. What's the opposite of? So remember, the cumulative always does or less. So what's the opposite of 8 or more? 7 or less. So the other thing I could have done, I could have just said 1 minus binom dist. Well, I want 7 out of 9.75 or less. And that would have worked too. So, right. Okay. And going back, is that unlikely? Probably. Is it unusual to find 8 have a green pod? No, it's not, because the probability is not very small. Okay, let's do one more like that, and then I'll try to skip down and find a Poisson one. Certain jet has 10 passengers. Is it wise to book 10 passengers for 12 passengers for the flight on a jet? Explain why. So what would be the probability that there's enough seats on the jet? How would I set that up? So how many people have to not come for there to be enough seats? 2, right? So go back. I'm going to do the same thing. If I want to find, well, the probability that there's 2 or less people would be binom dist 2 out of 12 with whatever that probability was, which is 0.0983. And I want or less, so 1, right? So there's an 89% chance that if 2 people's okay. 1 or less is the bad one, right? Sorry. 1 or less. Okay, there's a 66% chance that 1 or less people cancel, which means there's a 66% chance that there's not enough seats on the plane, right? So it's not a wise decision because probably there are not enough seats is, oh, there's no, it's not enough to do that. No. I hate all the reading we have to do in this problem. I mean, in these problems. Right. Okay. And let's see if we can jump down and find the Poisson stuff. Let's go to about 31. Oh, okay, let's do this right quick. This is still binomial. which for a general probability distribution, you have to do that whole find the mean by going x times probability, add them up. Standard deviation, you have to go x minus mean squared times probability, add them up. But for binomial, we said it was really easy because somebody did all the algebra for us at some point in the past. We got that the mean is just n times p, and the variance is just npq. So if you've got a binomial, finding the mean or standard deviation is really, really easy. So if you look at groups of 855, that's your n. Your p is the 52%. So just n times p is 444.6. And then same thing for standard deviation. Well, the variance is 855 times 0.52 times, I don't know if I ever said what Q was. Q is 1 minus P a lot of times. And so it's, if there's 52% chance they come, there's a 48% chance they don't come. That's what that is. So the variance is 213. How would I get the standard deviation? Yeah, square root. 13.6. So is the result of 454 voting election usual or unusual? So again, usual is usually 2 standard deviations. So anywhere from that's like double that's about 29. So the top end would be like 473 or something. If I go 29 plus that minus 29 would be like 414. So anywhere between 414 and 473 is about right. Well, there's more to this problem. Does it appear accurate voting results can be obtained by asking voters how they acted? I don't really like how that's, I'm not sure exactly what they're asking. But I don't think either B or C sound right, so I guess it's A. All right, now let's see if I can find the Poisson stuff.